What if you were asked to find the HCF and LCM of 16 and 20? You have two options. Either you find the HCF and LCM separately, or we find them together. Of course, we will find them together. All we need to do is use the common division method of finding the LCM. In the first step, we write the numbers separated by a comma, and then draw an L-shaped line like this. Then we look for a common factor of the two numbers and write it here. 2 is common factor of both the numbers. Then we write the quotients underneath. 2 times 8 is 16 and 2 times 10 is 20. Since these numbers are not co-prime, we go back to the second step and continue the process. They have 2 as their common factor, and 2 times 4 is 8, 2 times 5 is 10. We stop here since 4 and 5 are co-prime numbers. They have no common factors except 1. The product of the numbers in this L shape gives us the LCM of the two numbers. The LCM equals 2 times 2 times 4 times 5. That is 4 multiplied by 20, which equals 80. Yes, but how does this give us the HCF? Well, the product of the factors on the left gives us the HCF. Hence, the HCF will equal 2 times 2, which is 4. This is the HCF of 16 and 20. So you could see that just this one method gave us the HCF as well as the LCM of two numbers. But we also have to note that this works only for two numbers. There is another interesting concept about the HCF and the LCM of two numbers. First, let's find the product of the LCM and the HCF. LCM is 80 and the HCF is 4. The product will be 80 times 4, which equals 320. Now let's find the product of the two numbers. It will be 16 times 20, which equals 320. This will always be true. For any two given numbers, the product of their LCM and HCF will be equal to the product of the two given numbers. How do we find the HCF and the LCM of 72 and 120 together? It's simple. We use the common division process of LCM to find both. First, we write the numbers separated by a comma. Then we write the common factor on the left. Both these numbers are divisible by 2. 2 times 36 is 72 and 2 times 60 is 120. As they are not co-prime, we continue the process. Again, 2 is a common factor of both these numbers. 2 multiplied by 18 is 36 and 2 times 30 is 60. These two numbers are also divisible by 2. Here we get the quotients as 9 and 15. Are these two numbers co-prime? No, they are not. Both of them are divisible by 3. 3 times 3 is 9 and 3 times 5 is 15. The numbers 3 and 5 are co-prime because the only common factor they have is 1. So, we stop the process here. The LCM of the two numbers will be the product of the factors and the numbers in the last line. That will be 2 cubed multiplied by 3 squared multiplied by 5. That is 8 times 9 times 5, which is 72 times 5, which equals 360. And the HCF will be the product of the factors on the left. That is 2 cubed multiplied by 3. That gives us 24 as the HCF. Now here's a tricky question. We have to find the product of the HCF and LCM of 72 and 120. What would you normally do? Using the common division method, you would first find the LCM, then find the HCF, and then multiply them to get the product, correct? Yes, but this is not the quickest way. In the previous video, we looked at a property of the HCF and LCM of two numbers. The product of the HCF and the LCM of two numbers is equal to the product of those two given numbers. So we can directly write the product as 72 times 120, which equals 8,640. We didn't need to go through this long common division process to find the HCF and LCM separately and multiply them. We just directly multiplied the two numbers. There are two special cases we need to look at while finding the HCF and LCM of two numbers. First case, when one number is a multiple of the other, and second, when they have no common factors except 1, which means they are co-prime. Let's understand the cases in detail. The first case would have numbers like 4 and 8. 8 is a multiple of 4. Or numbers like 21 and 7. 21 is a multiple of 7. One number is a multiple of the other. Why is it a special case? It's because in such cases, the LCM is always the greater number. The LCM of 4 and 8 will be 8, and the LCM of 21 and 7 will be 21. And the HCF will always be the smaller number. The HCF of these two numbers will be 4, and the HCF of these two numbers will be 7. What about the second case? An example of two co-prime numbers would be 4 and 7, or 3 and 5. Both these pairs have no common factors except 1. What is so special about LCM and HCF of such numbers? Well, the LCM of such numbers will always equal the product of the two numbers. For the first pair, the LCM will be 4 times 7, which equals 28, and for the second pair, the LCM will equal 3 times 5, which equals 15. And what will be the HCF of such numbers? It will always be 1. The HCF of 4 and 7 as well as the HCF of 3 and 5 equals 1. But remember, these techniques should be used only to verify your answers. We have to find the HCF and LCM of 18, 20 and 30. How do we find the HCF and LCM of three numbers together? The best way to do it is by reducing all numbers to its prime factors, and then write them in exponential form. Let's reduce 18 to its prime factors first. It is divisible by 2. 2 times 9 is 18, and 3 times 3 is 9. So 18 can be written as a product of these three numbers. So 18 will equal 2 times 3 times 3. In exponential form, it can be written as 2 multiplied by 3 squared. Let's move on to the second number, which is 20. It is divisible by 2, and the quotient is 10, which is also divisible by 2. 2 times 5 is 10. We stop here as we got a prime number. 20 can be written as 2 times 2 times 5, and in exponential terms can be written as 2 squared multiplied by 5. And the last number is 30. It is divisible by 2, and 2 times 15 is 30. 3 times 5 is 15. So we can write 30 as 2 times 3 times 5. And in exponential form as well, it is written in the same way. Now that we have written all three numbers in exponential form, we can move on to find the HCF and LCM. To find the HCF, we multiply the smallest powers of shared factors. So let's find the HCF first. Shared factors are the prime factors that are present in all the numbers. There are 3 factors that we have to consider: 2, 3 and 5. And out of these, 2 is the only factor present in all the numbers. Now let's look at the powers of 2. We have 2 raised to 1, 2 raised to 2 and 2 raised to 1 again. The smallest power is 2 raised to 1. So our HCF will be 2. How do we find the LCM now? To find the LCM, we multiply the highest powers of each factor. For the LCM, the factors do not have to be shared. First, let's look at 2. 2 squared is the highest power amongst these 3. So we write 2 squared first. Among 3 and 3 squared is higher. We multiplied this with 3 squared. Notice that 3 is not present in here. It doesn't matter. For the LCM, we consider the highest power of each factor, whether it is shared or not. And the last factor is 5. We have 5 raised to 1 here as well as here. So we multiply this with 5 as its highest power. This is 4 multiplied by 9 multiplied by 5. That equals 180. So if you're asked to find the HCF as well as the LCM of 3 numbers, this is the method you should follow.